show by the principle of mathematical induction that for all n belonging to the set of natural numbers, the sum of the cubes of three consecutive natural numbers is divisible by 9. Okay, let us begin. So here we're going to consider a statement denoted by P of n. So here we have the statement P of n such that the sum of the cubes of three consecutive natural numbers is divisible by 9. So let us suppose the first natural number is n. So we are going to consider n cube. Then the next consecutive natural number is going to be n plus 1. That's we are going to cube it and then add it to the cube of the next consecutive natural number, which is n plus 2. Now let's say the sum of the cubes of these three natural numbers, this is divisible by 9. This is divisible by 9. So let this be the statement and we're calling it statement number 1. We need to verify that this is a true statement for any natural number that we pick up. That means any n value that we pick up, the statement must be always true. Now first what we'll do, we will check whether if it is true for n equals to 1 or not. So that means for n equals to 1, our statement P of 1 will become, we have 1 cube added to 2 cube plus 3 cube. So this is going to give us a value equals to, we have 1 added to 8 added to 27. So we have 27 plus 8, so that's going to be 35. 35 plus 1, so that's 36. And clearly we know 36 is divisible by 9. So 36 is divisible by 9. 9 times 4, that's 36. And this simply tells us that our statement P of 1 is going to be true. So P of 1 is a true statement. However, we need to check, we need to show that it is true for other natural numbers as well. So what we'll do, we'll begin by considering that P of m is true. So what does it mean when we say that P of m is true? That simply means that P of m, the statement can be the original statement P of n, that can be rewritten as P of m such that we have m cube added to m plus 1 whole cube added to m plus 2 whole cube. The sum of the cube of these three natural numbers, this is divisible by 9. So this is a true statement that we are considering, that's divisible by 9. So let's call it number 2. Now our goal will be to check if the next consecutive natural number, if we choose, it should be true as well. That means we need to show that P of m plus 1 is also a true statement. Now how do we show that P of m plus 1 is a true statement? What does it mean? It simply means that P of m plus 1 such that we have replaced each m with m plus 1. So that's going to give us m plus 1 whole cube added to m plus 2 whole cube added to m plus 3 whole cube. So the sum of the cubes of these three natural numbers must be divisible by 9 as well. Must be divisible by 9. And this is what we have to show. So how do we show that this is also true? So we will use statement number 2 because statement number 2 is true. So from statement number 2, we can say that if we take the sum of the cubes of the first three natural numbers, three consecutive natural numbers, m cube plus m plus 1 cubed added to m plus 2 cubed. So it's given here, this is divisible by 9. So here we can simply express it as a multiple of 9. So we're calling it 9 times lambda, where lambda is a constant belonging to the set of natural number. Fine. Now we have from statement number 3, m plus 1 whole cube added to m plus 2 whole cube added to m plus 3 whole cube. We're going to work with this, the sum of the cubes of these three consecutive natural numbers. So in place of m plus 1 whole cube and m plus 2 whole cube, we can use this equation and replace it with 9 lambda minus m cube added to m plus 3 whole cube. Fine. So this is going to be equals to, so we have 9 lambda added to, now what we have here is m plus 3 whole cube minus m cube. So this is the difference of two cubes. We have a standard formula for finding out the difference of cubes. So that's simply going to be, so we have m plus 3 minus m. This is going to get multiplied to m plus 3 whole squared. So we have m plus 3 whole squared then added to the product of m and m plus 3 added to m squared. Fine. So this is going to be equals to 9 times lambda added to, so m and m gets cancelled. So we have 3 multiplied to m plus 3 whole square added to m times m plus 3 plus m squared. Fine. Now, from each of the two terms, if we take 9 as the common factor, so we have 9 multiplied to lambda added to 1 over 3. This is going to get multiplied to m plus 3 whole squared added to m times m plus 3 added to m squared. So let's further simplify. Now we have 9 multiplied to lambda added to, so m plus 3 whole squared, and when we simplify all of this expression within the parentheses, we're going to get m squared plus 3m plus 3. Fine. Now we don't have to worry about the value of lambda plus m squared plus 3m plus 3. What we were been able to show here, that means if we take the sum of the cubes of the 3 consecutive natural numbers, m plus 1 whole cube plus m plus 2 whole cube plus m plus 3 whole cube, we are able to show that this is a multiple of 9. So in other words, what we have shown here, this simply tells us that m plus 1 whole cube added to m plus 2 whole cube added to m plus 3 whole cube, the sum of the 3 consecutive natural number, this is divisible by 9. If it is divisible by 9, that tells us that the statement P of m plus 1 is a true statement. So we are successful in verifying that the statement P of m plus 1 is true, which means that we can generalize this statement and we can say that P of n is a true statement. So true statement for all values of n belonging to the set of natural numbers. That means by taking help of the principle of mathematical induction, we were successful in showing that the sum of the cubes of 3 consecutive natural number is always going to be divisible by 9 for any natural number that we pick up. Hence proved.